Hi everybody. In this video we are going to talk about relative frequency, expected frequency, and observed frequency. And a lot of what we talk about here will sound very familiar to you. I'm going to start by reading this question. Chris Cross, it's a little joke name, likes to go scuba diving in Lake Michigan. I actually don't know if people do scuba dive in Lake Michigan. I just came up with a question like that. So far, he has seen a total of 30 fish, 10 of which were trout. Chris will watch another 240 fish swim by. For this situation, state the relative frequency regarding the number of trout already seen and the expected frequency regarding how many more trout will be seen. Okay, so let's take a look at these definitions. Relative frequency is the number of times a specific event has happened divided by the total number of events that have happened. So when we say events here, we're talking about fish. So the number of times a specific event has happened. So if I want to know the relative frequency regarding the number of trout already seen, then I want to know how many times Chris has already seen a trout. And it tells us in the problem that he already saw a trout 10 times. So let's write 10 over here. All right, relative frequency equals 10 divided by, so 10 over the total number of events that have happened, which in this context means the total number of fish that Chris has seen. And the problem told us that he saw a total of 30 fish. So it makes it easy for us. The total is right there, total of 30 fish. So we will put 30 in the denominator. And that is the relative frequency. Now that looks very similar to a probability, doesn't it? Where we have the number of good outcomes over the total number of outcomes. And you might be asking yourself, well, is this also the probability of seeing a fish in the future? And the answer is yes, it is the probability. It's a probability just given a different name. We use the term relative frequency if we're basically talking about observations which have already been made in the past. That's the context when the phrase relative frequency is often used. But since we do expect that the future is going to look a lot like the past, then the relative frequency also tells us the probability of something occurring in the future. So yes, this is the probability of seeing a fish in the future. Now let's go ahead and calculate the expected frequency. So what is an expected frequency, first of all? An expected frequency is the number of times we expect an event to happen. So this is our prediction. So I told you that a lot of what we talk about in this video will sound familiar to you. So if I have my relative frequency, which is really the relative frequency concerns what happens in the past, but since we expect the future to look a lot like the past, then the relative frequency is our probability. And in order, like we saw in the last video, in order to make a prediction, we need to take the probability and multiply by the number of attempts. In this problem, what we mean by the number of attempts is the number of fish that Chris is going to see. So he's going to stay in the water for a while. He likes scuba diving. He's going to stay there. And he wants to watch another 240 fish go by. So we want to make a prediction. Out of those 240 fish, what's the best prediction we can make for how many of them are going to be trout? Well, I'm just going to use strategy 1 from the last video. And in order to find my expected frequency, how many fish I expect to be trout out of the 240 fish he's going to see, I am going to simply multiply the probability, or my relative frequency, by the number of attempts. So my expected frequency, what I expect to see, Okay, just multiply the probability with the number of attempts in this case, that means the number of fish that Chris is going to look at. So 10 times 240 is 2,400, and 30 times 1, that's easy, that's just 30. I was about to say 1. Okay, so 2,400 divided by 30 would give us 80. Okay, so out of the 240 fish that that Chris is going to see, we would expect around 80 of them to be trout. And that kind of makes sense because let's reduce this. Both of these are divisible by 10. And we would get 1/3 there. So out of all the fish he has seen already, 1/3 of them were trout. If he sees 240 more fish, we would expect 1/3 of those to also be trout, and 1/3 of 240 is 80. So it all kind of makes sense. Now, what about, I didn't actually mention anything in the problem about the observed frequency, but I do want to talk about the definition. The observed frequency is the number of times an event actually happens. Okay, actually, I can scroll down a little bit. So, just because we expect 80 out of those 240 fish to be trout, that doesn't mean that when we actually observe them, or when Chris actually observes them, that they definitely will be trout. And we talked about this in the last video. We can make predictions, and we can make very good predictions that will come true, or very nearly come true pretty often, but we still can't predict the future exactly. So our observed frequency will not always be exactly the same as what we expected to happen. So maybe 82 of the fish will be trout, or maybe 75 of the fish will be trout, or maybe they're all trout, even though that's very unlikely. Okay, maybe 90 of the fish will be trout. The observed frequency, how many trout we actually observe in the water, will often be very close to the expected frequency. But if it's not exactly the same, that doesn't mean that we made a mistake anywhere. It just is because, you can't predict the future, right? So the expected frequency and observed frequency will not always be the same, but they are often close. It doesn't mean we made a mistake. This is basically what I've already said. What happened in the past is not guaranteed to happen in the future. No one can predict the future exactly. Okay, so I'm going to move on to the next problem. Okay, the next problem says Chris Cross likes to go scuba diving in Lake Michigan. So far, he has seen 30 blowfin and 10 trout. Chris will watch another 240 fish swim by. For this situation, state the relative frequency regarding the number of trout already seen and the expected frequency regarding how many more trout will be seen. Wait a minute, didn't we just do this problem? No, we did not. Look very carefully. What's the difference between this problem and the problem that we did a minute ago? Well, the difference is, in the first problem, this 30 over here was the total number of fish. In this problem, 30 is just another type of fish that Chris has seen. Or in other words, he saw 30 blowfin as opposed to trout. Okay, so 30 is not the total. In this problem, in order for us to figure out what the relative frequency is, we're going to have to figure out what the total is. It's not just given to us, but it's not hard to figure out the total. We'll just add these two numbers. So 30 plus 10 is 40, and we could still put 10 in the numerator since the problem is still asking us for the relative frequency regarding the number of trout. So we'll still put 10 in the numerator, and our relative frequency is 10 over 40. If we want to reduce that, we can divide this and this by 10, and we would get 1 over 4. So 1/4 or 1/4 of the fish that Chris has already seen were trout. again, we expect the future to be much like the past. So this relative frequency is our probability, okay, the probability that we're going to use to make predictions about the future. So if we want to figure out the expected frequency, what we expect to happen, we'll take our relative frequency and multiply it by the number of fish that Chris is going to see. He's going to see 240 fish. I can put that over 1 and then multiply the numerators and multiply the denominators. 240 divided by 4 is 60. Okay, so that is my expected frequency. We expect Chris to watch, to see, if Chris sees another 240 fish swim by, we expect that 60 of those will be trout. That's the best prediction we can make, although it's not necessarily going to happen because, again, the expected frequency and observed frequency will not always be the same, but they're often close, okay? So we might not see exactly 60 trout, but we're probably going to see around there, 59, 57. It's possible that only 3 out of those 240 fish are trout, but that's very unlikely, okay? So it doesn't mean we made a mistake if the observed frequencies and the expected frequencies are different, if what we actually observe is different from what we expected. Okay, what happened in the past is not guaranteed to happen in the future. No one can predict the future exactly. So I know I just read that twice, but all right. So I'm going to end the video there, and have a great day.